One of the most intriguing aspects of astronomy events is the potential supernova of Betelgeuse, which can be found in the well-known shoulder of the constellation Orion. Betelgeuse is a red supergiant star nearing the end of its cycle. Surprisingly, in 2019, one of the brightest stars in the sky began to fade. Being clearly visible to even the naked eye, its brightness diminished to such an extent that many observers wondered if the star was dying. Turning their telescopes toward it, scientists studying giant stars were astonished by the evidence of the great dimming. Betelgeuse is believed to be close to exploding into a supernova, marking the end of its existence. But when and why? Will the stellar explosion occur, and could it have devastating effects for Earth? Betelgeuse, a glowing ruby star, lies on the right upper arm of Orion the Hunter. You may recognize it by its other name, Alpha Orionis. Although it is the second, brightest star in its constellation behind the supergiant Rigel, it remains one of the most interesting to astronomers because of its variable behavior and peculiar name. Alpha stars are usually the brightest. Even though the star in the constellation Rigel outshines it in brightness, Betelgeuse is distinctive due to its size and reddish color. Betelgeuse, also known as Alpha Orionis, is one of the most famous stars in the night sky, being the 10th brightest and 7th brightest visible from the majority of North America, Europe, and Canada. Its name comes from Arabic and refers to the giant's armpit, in reference to where it is in the constellation. Betelgeuse loses about one solar mass every 10,000 years, ejecting materials evenly in all directions, forming a nebula around it. This nebula has a diameter of 30 astronomical units, which is 30 times the distance between the Earth and the Sun, and is 250 times larger than the star itself. At its core, Betelgeuse's hydrogen atoms fuse under immense gravity, producing helium and releasing light and heat in the process. As the star exhausts hydrogen, it begins to fuse helium and carbon as fuel. When the helium is consumed, neon reacts with carbon, forming iron. The fusion of iron releases no energy, causing the star to collapse under its own gravity and eventually explode in a supernova, one of the most powerful explosions in the universe. Depending on their age and evolutionary stage, stars emit light in different wavelengths, from the bright blue of young stars to the red of older ones. According to the ancient astronomer Ptolemy, Betelgeuse had a color that he curiously described as ruddy. However, astronomers in ancient China noted that Betelgeuse appeared to have a yellow color, suggesting that in the past it may have been a yellow supergiant. Large amounts of hydrogen tend to be used up by stars rapidly, bringing them to a premature end, even if their lifetime is only 10 million years. There is no doubt that Betelgeuse is in the last stages of its existence. While our Sun still has more than 5 billion years to go, Betelgeuse is nearing the end of its life, which means that it might at some point explode like a supernova, but the exact timing of this event remains uncertain. Betelgeuse goes through 2 brightening cycles, and one of the dimming cycles occurs every 5 years and lasts about 100 days. It is believed that the expansion and contraction of its outer shell during these cycles cause changes in its diameter and average temperature. Many paid attention to Betelgeuse because of its erratic behavior in 2019 and 2020, when its brightness decreased dramatically, only to briefly recover. Some astronomers have speculated that this conduct may indicate that the star is in the final stages of its life. Detailed studies of Betelgeuse date back to the 1st century BC, but the cause of its dimming remains a total mystery. Betelgeuse has been detected moving through the interstellar medium at a speed of 30 km/s. Being kicked out from Orion, where it came from, the OB1 association, which contains the stars, the shock arc stretches out from Orion's belt, more than 4 light-years away from the source. The distance to red supergiant stars like Betelgeuse, which is a well-known, difficult undertaking in astronomy, as multiple factors make it difficult to determine its precise diameter as well. The size of a pulsating star, Betelgeuse, changes with time. This phenomenon, together with the dimming of the stellar limb, causes its visual emission to dim and change color as we move away from the center of the stars. Researchers, using the Hubble telescope and other telescopes, discovered that Betelgeuse had ejected a significant portion of its observable surface, generating a significant surface mass ejection, SME. Although the Sun produces coronal mass ejections, the events at Betelgeuse had 1,000 times higher intensity with this theme, ejecting an amount of material 400 billion times larger than a typical solar coronal ejection. This explains why Betelgeuse experienced a rapid decline in brightness in October 2019. By mid-February 2020, it had lost about 3 times its luminosity, going from magnitude 0.5 to 1.7. By February 17, 2020, Betelgeuse's brightness had remained relatively stable for more than a week. On the 5th, it appeared that the star had stopped dimming completely. However, the recent visual fades were not related to the possibility of its core due to the absence of significant infrared changes, which were observed on February 24, 2020. Let me know what you think in the comments box. If you liked the video, hit the like button and subscribe so you don't miss out on more content like this one. When Betelgeuse finally explodes in a supernova, it will be one of the most spectacular celestial events in recorded history. Despite being 640 light-years away, the explosion will be so bright that it could outshine the full moon in our night sky, and even be visible during the day for weeks or possibly months. Astronomers estimate that the supernova will release more energy in a matter of seconds than our Sun will emit during its entire lifespan of 10 billion years. The explosion will race across space and eventually reach Earth as a brilliant point of light unlike anything we've ever seen. But don't worry, we are completely protected during a supernova. That close might sound dangerous, but Betelgeuse is still far enough from Earth that the blast won't harm our environment or life. What it will do, however, is provide an unprecedented scientific opportunity. As of recent years, Betelgeuse is back to its normal levels of brightness, but it's not consistent. Monitoring of the dimming cycles continues closely. Scientists are using instruments similar to the James Webb Space Telescope, Hubble Space Telescope, and ground-based interferometers like VLT and ALMA. They're observing fluctuations in surface brightness, convective cell patterns, and the persistent loss of mass events that seem to signal the star's instability. One popular theory is that Betelgeuse's great dimming was caused by a massive cloud of stellar dust created during one of these outbursts, temporarily blocking the star's light from our point of view. Understanding Betelgeuse could help astronomers unravel the life cycles of massive stars, especially those nearing supernova. This knowledge could assist us in understanding similar events in other galaxies, the chemical enrichment of the universe, and how elements like gold and iron are formed and dispersed through space. Betelgeuse is essentially a stellar time bomb, and it's ticking slowly. It may explode tomorrow, next year, or in 100,000 years, but whenever it does, it will offer us a cosmic light show and a scientific treasure trove unlike any other in recent memory.